Human activities in the effort of mankind to satisfy ever-increasing needs impact continuously on the environment, not only depleting natural resources, but also altering natural systems. Among the effects of human activities, those related to urbanization are particularly relevant, also because more than 50% of people on our planet live in cities. The reduction of vegetation and the increase of impervious surfaces cause strong alterations of the water cycle. Surface runoff is increased, while both evaporation and infiltration into the soil are decreased. These alterations result in important impacts inside cities: increase of flooding frequency and extent, increase of water pollution, decrease of groundwater recharge, decrease of river base flow, enhancement of heat island effects. To address these impacts and reduce the related risks, some strategies may be applied based on retrofitting of the urban environment with structures designed to counterbalance the alterations of the water cycle. These strategies are often called best management practices, sustainable urban drainage systems, or nature-based solutions, and involve interventions on 5 water-related processes: retention, infiltration, storage, treatment, harvesting. Retention of rainfall is achieved increasing the interception by vegetation and natural soil. The more rainfall is intercepted, the less surface runoff is produced during rainstorms. Intercepted water is then released back to the atmosphere by direct evaporation and plant transpiration, so also counterbalancing the urban heat island effect. In addition to existing urban green areas, interception may be increased by any new vegetated surface, for example, by creating green roofs and green walls on buildings. Infiltration into the soil may be increased by the redirection of stormwater runoff to existing vegetated surfaces, or to specifically design infiltration structures, such as rain gardens, permeable swales, soakaways, infiltration trenches, and bases. Permeable materials may be also used instead of impervious ones for pathways, sidewalks, courtyards, parking area, etc. They could be adopted also for roads when the traffic conditions make it possible. Vegetated infiltration structures are also able to intercept, as the other green areas, part of rainfall. The residual amount of stormwater that is not possible to be intercepted or infiltrated may be redirected to storage structures, such as detention ponds, underground tanks, urban lakes. Also, wild urban elements, such as squares, parking lots, public playgrounds, may be reshaped and equipped to work as temporary water detention areas. The aim is to use the storage process to limit the runoff peak flows with values compatible with the hydraulic capacity of drainage networks. It should be considered, anyway, that storage is not effective on runoff volumes that are entirely discharged downstream. Also, transported pollutants are only partially detained. Local treatment is then advisable, both on sewer inflows and outflows, to remove pollutants from stormwater before it may be discharged into the environment. Some infiltration structures provided with a storage volume, such as rain gardens, may be used for this purpose, acting as bioretention areas. They can be designed to take advantage of filtration, absorption, plant uptake, and microorganism biodigestion to remove a significant amount of pollution from water. Natural treatment of stormwater may happen also inside urban wetlands, that is, inside system of ponds characterized by aquatic vegetation, slow flow, and shallow water. Finally, Rainwater harvesting and reuse may be considered as a complementary action of stormwater runoff control, but it has also a great importance in terms of water supply service sustainability. On one side, it helps to reduce the stormwater inflow to drainage network, so reducing the risk of flooding and of environmental pollution. On the other, it allows to save potable water for uses that don't need such high quality, such as irrigation, gardening, toilet flushing, cloth washing, etc. In conclusion, the presented nature-based strategies are effective in counterbalancing the water-related impacts of urbanization, enhancing the sustainability and the resilience of cities in front of the present and future challenges from local and global changes.